Bismillah ar-Rahman ar-Rahim. Wassalatu wassalamu ala ashrafil mursaleen. We are here at Advanced Supervised Learning, and more specifically, it's boosting, and we are going to shed some light on Adaboost and XGBoost. Start by Adaboost, adaptive boosting. Well, as it says here, Adaboost uses probabilistic distribution. For now, it can be something weird, but if you went through what it says here, basically, well, we know that compared to the bagging classifiers, where we have several classifiers that work in parallel, boosting, it's a sequence of classifiers or algorithms, one after the other, one that deals with the mistakes or the issues of the previous one. But here it says Adaboost uses probabilistic distribution. What is it about in a nutshell? Look, as it says here, input training set. It's the same for both algorithms. I'm just giving you a rough idea about it. It's not that a problem that will need some exercise, but I need you to at least understand what is going on here, and as I said in the previous video, clear some misconceptions. It says input training set T of n examples, and then this is the probability of picking one element. Imagine we have 10 elements, so the probability of picking one number or one element is 1 over 10, and all of them are equal. And for some who still don't have a clear idea about what is that bootstrapping thing where we pick and put back, look, here it says create a subset Ti. Why Ti? Because for each classifier it has an I. The first classifier, the second, the third, etc. Consisting of n examples. You see here that n example for the subset and n examples in the root dataset. So it has the same number of elements. So where is the trick here? When we create the subset, for example T1, it means we go to the root dataset or the original one, we take an element or we make a copy. If we are speaking physically, we mention, we put it back. We mention it, we took it, and we put it back. So always it has a 1 over n probability to be taken. And we do this n times, so we end up with n elements, given the chance of 1 over n to get each element. This is, I hope it's kind of clear now what these two lines. The rest is some mathematical formulation to adjust the probability, since Adaboost is relying on the probability. So the idea here, if we go to this exercise, the original data set, it has, as you can see, from 1 to 10, so we have 10 elements. Then the probability of each element is 1 over 10, which equals to 0.1 probability. When we sum them equals to 1, so this is logical. When we train a classifier on this, later it will get an accuracy. Suppose we have, let's see the example used here. Well, suppose that classifier C1 classified correctly. Well, it classified from x1 to x7, from here to here. So 7 over 10 are well classified. 3 over 10 are misclassified. We agreed upon this. We have this term. This term, it means if the prediction is wrong, so E of that prediction equals 1. If it is right, it equals 0. So we are just going to take the misclassified or make effect on the misclassified. To calculate the error, we sum only the errors. Let's come here and we see we sum from the 1st to the 10th. All of these are multiplied by 0. As you know, they were well classified, but these are misclassified, so that E of x equals 1. So E of x multiplied by 0.1, it equals to 3. The rest is multiplied by 0, so we don't take them. So the sum of these, it will equal to 0.3. This is the error. And the beta, if we come to my Obsidian notes, we are going to see that beta. The beta, and what it does, it compares how much the classifiers gets wrong to how much it gets right. So this is the error. In our case, it's 0.3. So 0.3 to 1 minus 0.3, it's 0.3 to 0.7. This is our beta, and this is the best definition I found. Beta is penalty factor. So it penalizes the error. And why we will need it in the lecture notes example, you can see that. So this is the formula of beta. By seeing how it is used, you will better understand. Now we calculated the beta. The beta is 0.3 over 1 minus 0.3. 0.3, let's bring the calculator. 0.3 over 0.7, and here you can see that 0.343. So now this is the original probabilities of our data. Now what we are going to do, we are going to multiply. Let's go to the rules. Modify the probabilities of correctly classified. As you remember, the Adaboost or later the XGBoost, they try to deal with the misclassified by multiplying this 0.43 by the probabilities of these well classified. It means we are going to reduce their probability, and we are not going to touch the misclassified, so we are going to reduce the probability of the well classified and keep the others non-touched. And then we do the normalization. Why we are doing the normalization? Because when we are supposed to have the sum of all the probabilities equal to 1, and you will see that in example. So we got the error, then we calculated the beta of the error, then we did this multiplication using this formula or this one. They are just a variation. So what you should take from here is that it reduces the well classified, it doesn't touch the well classified. This is the most important, because later when we build the next classifier, we are going to, as we did in the first instance, we pick randomly but with highest probabilities for the misclassified and lowest probabilities for the well classified. This is how it deals or gives more attention to the badly classified instances. This is the idea of Adaboost. The rest is very simple. Now, as you can see, we multiplied that beta by the probabilities, but as I said, we are supposed to have one. We did the normalization here. So as you can see, from not 0.1 it became not 0.07, and the probabilities of the misclassified is higher. So this is the idea of Adaboost. And don't worry about it, at least you had the idea of how it works.